folks, let's take a look at solving some rational equations. So I'm going to do 2 of these at a time. And for here, I'm going to solve, I've got number 1, I've got denominators of 6k squared, 3k squared, and k. Over here I have n squared n and 2n squared. And for me, whenever I have rational equations, meaning, again, rational meaning I have fractions, which I do, and then equations meaning I have equal signs, which I do, I'm going to find the LCD, and then I'm going to multiply every term in that equation, every fraction. Well, really every term, they just also all happen to be fractions, but I'm going to multiply every term by that LCD to knock out the fractions. So if I look over here on number 1, my LCD, I need to take into account I have a 6 and a 3 and a 1 in terms of the coefficients. Right, so 6, 3, 1, the least common multiple there is 6, so I'll cover my bases with 6. Between k squared, and k, I always take the highest exponent. So this is technically k to the 1, so I have a 2, 2, 1, so the highest exponent I saw was k squared. All right, so that will ultimately be my LCD for number 1. And similarly over for number 2 for my LCD, when I start to look at this, if I look at the numbers, right, I have a 1 in front of the n squared, a 1 in front of the n, and a 2 here. Least common multiple there is 2. Between my exponents on n, because my only other factor is the letter n, I've got n squared, n to the 1, n squared, so n squared is the highest exponent, and that will ultimately be part of my LCD. Okay, so let me erase my little notes about the exponent of 1. So once you determine what your LCD is, what I'm going to do is I'm going to take 6k squared and multiply it to this fraction, this fraction, this fraction. And by design, we will get rid of fractions. So let me take 6k squared and multiply it to 1 over 6k squared. And I'm going to write small here because I'm going to run out of space pretty quickly. And then I'm going to take 6k squared and multiply it to 1 over 3k squared. And then I'm going to take 6k squared and multiply it to 1 over k. All right, and then some canceling should happen. So the 6k squared cancels completely with the 6k squared here. The k squareds cancel out on this second term. That leaves me with 6 over 3, which will ultimately be 2, right? 6 is in the numerator, 3 is in the denominator. Here, I have a k and a k squared, so I can lose the whole denominator, but that still leaves me with a k up top. So I'm going to x out or cross out the exponent and the k down here. So on the left side, I have the number 1, right? 6 over 3 is 2. And then we had 6k times 1 here, so that would be minus 6k. All right, and then I have a linear equation. And I say linear equation because, again, I still have my equal sign, but k is now just raised to the first power. So I need to isolate that linear term. I'm going to subtract 2 from both sides. When I do that, I get negative 1 equaling negative 6k. All right, and then I'm going to divide both sides by negative 6, and I personally like to write my variable on the left side, so I'll divide by negative 6, right? By design, that cancels out, and I'm getting k equaling positive 1/6. And it's always good to check that whatever number you get for your answer doesn't ultimately make your denominator 0. So in this case, the only way my denominator would be 0 is if if k was 0. So if I did all this algebra work and I got k was 0, I would actually have to throw that solution out. Similarly here, I'm gonna do number 2, and I'm gonna multiply everything by 2n squared. Let's say I get to the end and I had n equaling 0. If I got n equaling 0, I would actually throw that answer out because that would make the denominator 0. But let's see what we get. I don't necessarily think we're gonna get n equals 0 over here. All right. So let's take a look. I'm going to multiply every term by my LCD. So 2n squared times 1 over n squared plus 2n squared times 1 over n. That should equal 2n squared times 1 over 2n squared. So as we start to cancel, the n squareds cancel, a power of n cancels, and then the entire 2n squared cancels here. So here I have 2 times 1, which will be 2, 2n times 1, which will be 2n, and that will ultimately equal 1. So again, linear equation with just n. Let's subtract 2 from both sides. All right, that's going to leave me with 2n equaling negative 1. And all I need to do then is divide both sides by 2. Right? We just keep doing inverse operations. I get n equaling negative 1/2. That's great. I will keep this answer because that does not make my denominator 0. So for number 1 and 2, I got k equaling 1/6, n equaling -1/2. All right, thanks so much. Bye.